Hi, everyone. That's terrible. Try again, try again. Hi, everyone. Okay. So seems you have your coffee in the morning. That's better. Appreciate that. To be honest, I was expecting an empty room because just right now, Josh along with Sebastian have started a talk on Kotlin. So thank you very much for coming, and I hope you are in the right room. A small info about me. My name is Nakul Mishra. I'm an independent consultant and contractor with a zest for open source software. I work for a company called Casumo. Casumo is a Swedish startup founded in 2012, where the founder chose DDD and CQRS to address the business needs. As a matter of fact, we have an event store with billions of events. We produce millions of events every day. And every event is important because we don't know on which event a person will lose a cent or end up winning millions. And we have an amazing culture. How many of you like playing with Lego? No one, no one. No, I see most of you. I always loved to build Legos when I was a kid. Actually, I still love it. The idea of having the possibility to build beautiful structures starting with a single beautiful piece just amazed me. I always felt that the key to complexity is simplicity. You build complex systems starting with simple ideas. This is what I love and what I want to talk to you today. I would like to show you how easy it is to access a battle-tested technology like Kafka from a developer-friendly framework like Spring. I will also like to share a bit of our experience on what challenges we faced, and more importantly, how Kafka and why Kafka was able to deliver on those challenges. Before we dive into Spring Kafka, it's important to have a bit of overview on what is Kafka. For the starters, Kafka is not an ESB. It's true that we can pull and push data from a variety of data stores using Kafka, and we can manipulate data in flight. It does not make Kafka an ESB. For ESB, the center of attention is integration with legacy and off-the-shelf systems. Moreover, the messaging layer doesn't excel when it comes to messaging throughput. And finally, central team dictates a lot when it comes to schema, transformation, registry, leading to a centralized approach, which makes it hard for an individual service to scale at its own pace. However, no one stops you from shooting in the foot. Hence, we should really stay away from recreating ESB anti-patterns with Kafka. Kafka is more than a service, more than a messaging queue. It supports both point-to-point and publish and subscribe model. The broker is insanely fast with message throughput and can replay messages all day long. So replaying messages with Kafka is not a problem. And it does not even slow down as the number of consumers increase, a problem which is quite common with traditional messaging system. The broker is obviously horizontally scalable, and even it provides stronger guarantees than a traditional messaging system. And it's a big claim. How come Kafka can provide such guarantees? Well, let's take a look. So in a traditional messaging system, we have a queue that retains record on the server. We can have multiple consumers here, and if multiple consumers consume from the queue, then the server indeed hands out the records in the order they are stored. However, the records are delivered asynchronously, meaning that they may arrive out of order on different consumers. Hence, the ordering of the records may be lost. So when we have a parallelism and multiple consumption, it doesn't go hand in hand. What is the solution that traditional messaging queue use? Well, they rely on a concept of exclusive consumer. Kafka, on the other hand side, have a notation of parallelism baked within the topics. Kafka divides a topic in partition, and when assigning the partition to a consumer group, it makes sure that each partition is consumed by exactly one consumer in that group. So If we have a topic is divided into partitions. Topic is just a logical representation. And a consumer belongs to a consumer group. When a consumer joins the consumer group, a partition is always assigned to one and only one consumer. However, a consumer can consume from multiple partitions. What happens if we have, that's terrible. What happens if we have multiple consumers joining the group? So we had a consumer C1 and then C2 joined. Well, internally, a rebalance get triggers in Kafka and partition get reassigned so that the load is evenly balanced. In a nutshell, Kafka is able to provide both ordering guarantee and load balancing over a pool of consumer processes. If we take a look on a traditional database consists of number of components like commit log, query engine, indexes, caching, you name them. And all these components are bundled together in a black box technology. Turning the database inside out is a term coined by Martin Kleppmann. And what it means is we can split those components found in our traditional database into separate parts and glue them together. Kafka can be perceived as a database inside out, where different parts can be glued together via Kafka commit log. For example, we can have a stream processor like Kafka streams, and we can use them to create indexes or views. Think about views as some sort of a cache. The benefit of this cache is that A, you can choose to decide where it lives, meaning it can live inside your application or outside or close to your application. And B, it is continuously updated. However, please keep in mind that KSQL and Kafka streams are optimized for continual computation rather than batching. Kafka is designed to move data and operate on the data when it is moving. So the best way to describe Kafka is that it is a streaming platform. There are a bunch of APIs which we can use to talk to this streaming platform. So first is a communication API. So we can use basically different API clients. You know, they are provided in various different languages to communicate with Kafka. Next, we have a connector API. And what connector API does, it's a sink and source. So you can pull data from an existing system and push it to Kafka and vice versa. And it supports S3, JDBC, HDFS. So when we were migrating our system, it comes quite handy. Streaming APIs are provided in the form of Kafka streams and KSQL. Basically, think about them that we can use them to filter the data, or we can execute arbitrary function as the data evolves. Please note that these APIs can be stateful, meaning that they can hold the records like traditional database tables. And finally, we have a bunch of utilities in the form of schema registry, replicator, mirror maker, and Confluent have their own platform. $1 million question is what leads us to Kafka? And the answer is our challenges. Spending time with Lego taught me in early age that every piece has its own place and purpose in the picture. And no matter if you try to use different piece, no matter how hard you try, it simply doesn't fit. And that was obvious in that Lego sense. However, in software engineering, the same thing happens a lot. The only difference is that it is not so apparent at the first place. And what we were trying to do is we were trying to use traditional messaging system in a distributed world. And it brought 3 challenges for us. Namely, scalability, speed or velocity, and finally, resiliency. So these were the 3 main challenges or our pain points. I hope it rings a bell, because these are something which more or less most of us encounters. However, we also saw an opportunity when experiencing those problems. The problem with traditional messaging system was that they took a broker-centric approach, meaning a broker does a lot of housekeeping in the form of message tracking. Just to give you an idea, message tracking by nature is hard because a broker needs to maintain a lot of state. It have to make sure which messages are sent, which need to be redelivered, acknowledgement, and whatnot. Kafka, on the other hand side, changed the game. It took an opposite road. It chose to have a dumb broker and smart consumer, and where consumer took over many of the functionalities of a traditional broker. A traditional broker, and what it demanded in return is an insanely fast and scalable broker. Most traditional message brokers are built using index structures. So they use some sort of a B tree or hash table in order to build the index structures. And they use them to manage acknowledgement and when the message is removed once they are read, and so on. The problem is that these indexes come at a price. They need to be maintained, and there is a price to pay. They must be kept in memory in order to get good performance. And this part leads to this problem, that retention becomes some sort of a limited. But Kafka chose a different approach. And what it does is it uses a log structure. We will see in a couple of slides what log structure is. And the benefit of using logged up structure approach is it provides constant performance, O1. So while if you read or write a message, so from Kafka perspective, it doesn't matter whether the data is in memory or is sitting on the disk. Finally, there are outrages in production. And traditional brokers tend to slow down as they start to get full because messages starts to pile up. Whereas in Kafka, it was, and it is not a problem. We didn't experience any significant slowdown as the queue starts to increase. But all of this sounds too good to be true. So let's focus a bit on why Kafka could solve those three challenges. Well, if I have to answer it in one line, I would say Kafka embraces immutability. There is no conference where the word immutability doesn't come. So we are doing this ritual here also. Kafka embraces immutability at a design level, and believe me, it changes everything. Today we are here in a beautiful city of Barcelona. I come here quite often, and while I was walking here, it made me think about my Lego times. How the city was built. I found out that the civil engineer, and I found out thanks to my Spanish friend, who is sitting in the audience, that a civil engineer was appointed in 19th century, was given a task to plan the city's expansion. But there was a small problem. He couldn't find a suitable reference work. So, as a good engineer does, he rolled up his sleeve and he undertook the task of writing one from scratch. He borrowed a few technology ideas from the contemporaries to create a unique design. And the key of this design that it was considered thoughtful rather than whimsically. His layouts were optimized for pedestrian, carriages, even urban railways. No one have even heard about those. And he even went to this much extent that he thought about the calamities. So there are large capacity sewers designed in this city to prevent frequent floods. And on top of everything, like if he have nothing to do in life, he just couldn't neglect the key amenities like public and private gardens. His design made Barcelona as one of the easiest cities in the world to navigate without GPS. Kafka is designed keeping distributed world in mind. That decision was made consciously, rather whimsically. And at the heart of the Kafka messaging system, there is a log which promotes sequential operation when it comes to both read and write. So when you are writing to Kafka, what happens is just you write to the end of the file, that is append only, and when you read, a single seek and scan is performed. Kafka, crazy enough, this design of log structure, if you reflect how many benefits it provides, are insane. Because now Kafka, using this log structure approach, able to design a data structure which is hardware friendly. meaning that it can leverage on the shoulders of giant. Kafka piggyback on OS for catching, batching, and prefetching. And even this cache stay warm even if the service is restarted. As a matter of fact, this design is so good that when we are reading messages from Kafka, we can avoid copying messages into the JVM space and don't bump into issues like GC and heap and so on and so forth. So what happens with us is that since Linux supports zero copy operation, meaning that you can just copy data directly from network from the disk to the network interface, meaning you can avoid bypassing, so normally, traditionally, it works like this. You have a data, it goes to the JVM space, and then JVM space to the outside. But in Kafka relies on Linux, and Linux supports zero copy, which means you can just copy data from disk to the network. And that was insane for us, because what happened is we could finally saturate the network and start using the bandwidth which we were paying for Amazon. If you wonder how this massive throughput works, you can take a look on java.neo.channels. Basically, this method, transfer2, is used internally. And it depends on the underlying operating system for the support for zero copy. So don't run it on Windows. And also, it depends on the various flavors of Linux. Since log is hardware friendly, it comes as no surprise that it can span across multiple machines. And Kafka takes care of providing necessary building blocks in the form of reliable routing, failure handling, and so on to make it all work together. And Kafka is about, just to give you an idea, like this scale, it's practically impossible to hit the scale limit with Kafka, because I know I checked last time, New Relic is doing like 30 gigabyte per second with a server of 100 nodes. And LinkedIn and Netflix, and they are like doing trillions of messages per day. We were able to write extremely fast using Kafka. And why is that? Because in Kafka, the writes could be fast only if Kafka could avoid sync operation. And Kafka indeed avoids it by relying on replication, making it first-class citizen at a design level. The end result was that we could use a Kafka broker, give it a 64 gig of RAM, and it outperform 1,000 times than a traditional messaging system. And just to tell you, there were no fancy machine brought here. This is not like we bought something which had massive, processors or something. It was less resource. It had less resource even than our normal messaging system on the machine or hardware on which we run. Kafka is designed to be resilient. I mean, it literally is designed to be resilient. Think about Kafka as a helicopter, which was, I think, during World War, it was designed that which could just pass by and shoot. It was like one of the very funny invention, I would say. Like, it could just shoot the tanks, and it flies so low. However, it was so effective in one thing, that it could destroy the tanks, and even if its glass is lost, half of the wing is lost, tail is on fire, it will still make back home. And Kafka is extremely resilient. It has the concept of leader and followers, nothing new. However, since they thought about replication at a design level, what we have is we have a concept of in-sync replicas, meaning that there are some followers which are in sync with leaders. And if for some reason broker who is acting as a leader for a partition blows up, any broker can take over for that partition. Finally, we were missing a last piece of the puzzle. That is, we wanted to try and test our ideas and at the same time start shipping those ideas to see how they work at scale. And that's where Spring Kafka came handy. First of all, it opened the door to Spring ecosystem. Secondly, it saved a good chunk of our time because we could get started with Kafka in no time. We didn't have to learn all the APIs and stuff like that. Moreover, it made some improvement over default things provided by Kafka. So for example, headers in Kafka are just key and value, where key is a string and value is a byte array. There is nothing wrong with that, but when we were working, we wanted to send a foo over the wire in JSON and get serialize and deserialize, and it saved a lot of our work, a good chunk of work, I would say. Also, it have a support for Kafka streams, and Kafka stream, again, we can access the header. Finally, it made testing Kafka a bit more simpler. We have a embedded Kafka, and we will take a look on the demo now. And it introduced test utils like condition, helper methods, and so on and so forth. Testing Kafka was not terribly like bad thing to do, but the thing is Spring really nailed it. So we have annotation supports and embedded Kafka broker and so on and so forth. All right, so let's jump into demo. And now is the problem, I cannot see this. Okay, I will try to operate it only from here. All right, so the first thing is, how can we start sending messages to Kafka? Well, there is something called Kafka template provided by Spring. We can invoke the method called send, passing the name of the topic and the payload, hello in our case. However, if I execute this piece of code right now without this annotation, it will blow up because I don't have a local Kafka broker running. So I can use this annotation, and this annotation is provided by Spring Kafka. And what this annotation basically does is it boot up an in-memory instance of Kafka broker. And under the hood, what happens is we have a Kafka broker, which is running in memory, and a zookeeper running in memory. And obviously, I can control how some of the settings here. So I can say, for example, how many number of brokers I want to run, which topics I want to create, the replication, the partitions, and so on and so forth. So if I execute this now, I think this one. So hopefully it should pass. And indeed, one more thing which is worthwhile to note is, if for some reason you want to access the embedded Kafka during the test, you can do it easily using Kafka embed. And what you do is you just auto-wire it in your class, and then in your test you can just use it as a normal Java bean. So you can say Kafka embedded.getBroker as string, for example, and it will output the address of the in-memory broker running, hopefully. So as you can see, we not only can ask the question, but we also have the access to zookeeper client. So I can say Kafka embedded.getZookeeper client. So this is what we can do. However, if you like JUnit, the Kafka embedded can also be used as a class rule. It's provided by Spring Kafka. Or if you are using some different testing framework, what you can do is you can use Kafka embedded as a normal bean here. And just remember to call before and destroy method at some point during the life cycle of your test. And what before does is basically it set up the Kafka broker and everything up and running, and destroy just shut down and release the resources. However, we have seen three approaches to use Kafka, like annotation, JUnit rule, and the last is this embedded Kafka as a bean. However, if you are developing okay. Okay, let me. I was not prepared for this. Let me find the settings. It will be much faster. Where is it? I don't know. 20? Okay, let's do it maybe 16. And hopefully it will be good. Okay. So where I was? Oh yes. So we have 3 ways to use the Kafka embedded. But however, if you are developing a lot of tests, it's expensive to fire a Kafka broker per test class. I mean per test class, not even per test. It is expensive. And what we experience is the build time on the CI started to bump up. It's something which is not so nice. So what you can do is you can do something like this. So what you can do is you can create a class which is a holder, and it holds the instance of Kafka embedded. And then your test classes, you can just ask the holder to give you the instance of the embedded broker and then start adding topics. However, as of Kafka version 2.1.6, this approach is, okay, I have to exit here for a while. The presentation mode. Okay. However, as of Kafka, holder. Okay. So as you can see, the code which I show you is exactly the same which is listed on the documentation. The reason why it doesn't work, or let's say it works but not fully functional, was this issue that when we were adding, when the topic was created by like this, the topics were added in the Kafka, but they were not added in the embedded holder. Hence, I open an issue and fire a PR, and it's already merged. So the thing is, if you want to go home and want to try this approach of using a single broker or number of brokers across multiple test classes, just wait for a new version of Spring Kafka to come out. Okay, back to here. You know what? I can maybe mirror my display. It will be much easier for me. Displays. Mirror the display. Okay. All right, it's much better now. All right, so this is all about testing. So I forgot to mention that the demo is divided into 4 parts. First, I will show you a bit about testing. Then I will show you how we can produce messages to Kafka. Then about consuming. And finally, I will mention about Kafka, how we can synchronize the transactions in Kafka. Till now, all we did is we just, send some messages to Kafka and assume that everything got published nicely. However, there is one thing which we could do in order to make our test a bit more legitimate, is we can publish the message and consume it. In order to consume messages from Kafka, you need a Kafka consumer. Spring Kafka provides us something called default Kafka consumer factory, and all we need to do is we need to pass what sort of configuration we want to use for generating the Kafka consumer. And if you take a look here internally, this is nothing but a hash map with some sensible defaults. And it comes handy because when I'm developing a test, the last thing I want is to find some errors because I use some wrong defaults. One thing to note here is that I'm doing here explicit flush. And why is that? Because when I said Kafka template take care of publishing the message, what happens is that internally it delegates to Kafka producer. So when you send something to Kafka, the Kafka producer does not hand it out immediately to Kafka. What it have a small buffer, or buffer size can be tweaked depending on the configuration. And then depending on your properties which you configure in application.properties file, it will flush the buffer. So during test is nice if you flush, just to make sure that you don't have flaky test. And finally, I'm saying that it should have a value of payload hello. So if I run this test, the payload should be hello. And then I can show you that this test is indeed legitimate by running it, and hopefully it will fail. So as you can see, it fails now because I have hello XXS. Spring Kafka also made testing a bit more easier, not only in terms of annotation, but also providing us a form of assault J conditions, which help us to improve the readability. So here, as you can see, I have received a record, and what I want to do is I want to say that it have a key null value hello, partition 0, timestamp. Basically, they are assault J conditions created by Spring Kafka called Kafka conditions, if I remember. And they make your test a bit more readable and easy to read. The same support is provided if you are using Hemcrest matchers. So as you can see, you can just pick even some small tools. Even if you don't want to go for full Spring Kafka, you can just use even a testing library. And that's how even I started developing with it. The next thing is about sending messages to Kafka. So what happens when we send a message to Kafka or publish a message to Kafka? We don't know whether the message was succeeded or it failed because we just send. So what send does is it returns a future. So as you can see, it returns a future. What we can do is we can either say future.get and wait for it to return, but it will end up blocking the thread. So what you can do is more nice thing is add a callback and pass here, for example, listenable future callback, and say on error, just print the exception. This is for demo, so don't do it in production. And here we have a result, and with result we have access to producer record. And this producer record is coming from Kafka. So you can say here, for example, I don't know, get topic, and run it. Oh, and I forgot, we should put the thread to sleep just in case. Oh, no, it was fast enough. So we can get the results here. Finally, the last thing I want to show you with the Kafka template is, by default, it operates on string and string, meaning that the key is string and the value is also string, or byte array, to be more precise. However, what if you want to send some integer over your Kafka broker? What you can do is you can configure a Kafka template to use, which just know how to send integers to broker. However, to be more precise, what you need is you need a producer which know how to deal, because Kafka template just delegated to Kafka producer. So creating producer is super easy. We have like consumer factory, we have a producer factory, and we can just pass bunch of configurations. And again, if you take a look, what happens under the hood is that we have a key serializer which is configured as integer serializer. And then we can just tell the Kafka template that use this particular producer factory. However, note here I set auto flush to true. Don't do it in production. I mean, you're gonna regret a lot. Why? Because what is going to happen is on every send, the Kafka producer is going to flush the record. And that is not nice. I did it only for test, just to show you that for testing, I didn't want it to say template.flush, so I configure here. But just be aware that flushing comes at a price, and at a big price. And if I execute it, this test here, I hope it will also pass. All right. So this is all about, publishing messages to Kafka. How can we start, consuming messages from Kafka? So first thing, oops. So what we can do is we can use an annotation called KafkaListener, and what this annotation does is basically it takes care of invoking this method. It's like a Kafka consumer, which get invoked under the hood by Spring. So if I execute this, for example, demo 2, or where it was, demo, let me find it. Oh, so if I run this method, what is going to happen is this method is going to be consumed. So it is my Kafka listener which is up and running, and the heartbeat and everything is taken care of. I also have the possibility to access the consumer record. So here, as you can see, for example, I can access the consumer record and can get a bit of more information when it comes to consumer record. I can also tell the Kafka consumer to consume from a particular topic, and the syntax is pretty straightforward. All you have to do is just pass add topic partition and the name of the topic and which partition you want to listen. And you can pass here like one partition, or you can pass here bunch of partition. Also, we have something which is super handy is if you want to tweak how your Kafka listener behaves, because under the hood it is just a message listener. And what you can do is you can just pass a container factory here. And container factory is just a bean. So you can create a bean and it get injected. And that's how you can control the behavior of Kafka listener. Here I have just done the bare minimum for the demo purposes, but you are free to do things like set I don't know, concurrency level. So you can specify how many threads will be used. Finally, I will like to show you two more things. And if we, for example, encounter some errors, then we can specify the error handler. And what happens is, like many times you can get a record and consumer process it, but blow up, encounters an exception. And in that case, what you can do is you can specify an error handler. And I like to use consumer-aware listener error handler rather than a generic, just rather than implementing this interface directly. So I can implement something like return new and Kafka listener error handler. But in that case, I don't have access to consumer. And usually when an error happens, you want to tweak some offsets or know what was consumer doing that time. So consumer-aware listener is provide an easy access to the consumer. Also, if you want, you can access the headers directly using annotation like @header. So if I just quickly run this, and in the test, you can see I'm setting the topic and the partition, and they are sent as header. And Kafka, Spring Kafka take cares of sending the headers. Basically, delegate using some sensible defaults. Last thing is when it comes to compacted topic in Kafka. So I don't know how many of you are aware with compacted topic, but basically the idea behind compacted topic is you want to retain just the last value. So you don't care about all the values, you just always want to have the latest value. And in Kafka, if you want to delete something, you just pass null as a value. However, if you try to invoke pass here, like if I show you very fast, so just let me comment it out. And if I send here a null payload, what will happen is it will blow up because it will say me that null payloads are not accepted. So what I can do is I can, yes, as you can see here, that it is saying. What I can do here is I can say required false, and it allows us to deal with null payloads. So this is about Kafka Listener. Here, as you can see, in all these code samples, we are using Kafka Listener on a method level. However, we can also use it at a class level, and that's where things starts to get interesting. So imagine, so we can use Kafka Listener along with Kafka Handler, and they are introduced like not long before the Kafka handlers. And basically, imagine a scenario in which you have a topic, Kafka topic, for example, fruits in this case, and you have partitions in which messages are mixed. So you have one message which is foo, and another message is bar. So when you are reading, previously you had to do a lot of JSON serializer and deserializer and all that stuff. However, Spring Kafka make the life really, really easy. So first, let me show you what happens if I execute this test at this very moment. I should get an exception here. And as you can see, the exception happens, and the reason for this is because when we use Kafka Listener at a method level, it looks at the type information. But now we are in a problem because we have a bean which have two handlers, so it can handle apple and banana. And when we are invoking any method, it doesn't know which one to invoke. So what we can do is we can create a message converter and basically tell there that look at the type ID to find out the payload type. And what is this type ID? Well, type ID is, so let me tell you two things in order to make it simpler. First of all, the test hopefully will pass here. And it indeed, so you can see I have apple and banana. But what happens by this message converter? So if you take a look in Kafka auto configuration, Kafka auto configuration, there is a message converter bean, and this bean just basically extends the message converter. So it gets injected in a Kafka template. And what we did is we just injected our own bean there. And doing that, we said that we want to use type ID, and type ID is present in the record header. So let me show you how the type ID looks like when we configure this message converter. So let's go to demo 3 test. So here when we do a send, and let me just put a breakpoint here, let's execute it. So if you take a look here, I have what I have here. I have a record. So I have a producer record, and if I call the headers, you can see I have some header, and this header have a value called type ID. It's just Spring Kafka does it for me. And you can see the value is a byte array here. So since if we convert the byte array to string, you can see it is the name of the class, which is the name of the package and the class in that package. So that's where the type ID comes from. Now I would like to show you a fifth demo, which is about how we can synchronize transactions in Kafka. So I need to do a few things. Let me just rename it to application.foo, and I just rename it to application.txn, and enable in build.gradle, Spring Data JPA, and MySQL. So sometime what you need is, oh, and also last but not the least, mark it directory as cancel exclusion. So sometime what you need is, and this is, I still find a valid use case of this in production. It is only good for demo. you know. So you know, learn about it, but think before using. Sometime what you want is you want to commit to a database and commit to Kafka, and you want to roll back if one of the actions go bad. Spring Kafka, we can do it in Spring thanks to something like creating a chain transaction manager and passing there JPA and Kafka Transaction Manager. However, the catch here is that, first of all, Kafka transactions are not XA transactions. They are, so what happens under the hood is you have two transactions going on, one is committed and then another is going to be committed, and then the hell breaks down. So we are going back to the dinosaur age in life. So just be really watch out for all that stuff. Just to show you that it works, I can execute this test here. Let's run order application. What is it? Ah, yes, thank you. I was thinking what went wrong. Thanks. So as you can see, we run this test, and if we take in the order database and refresh it, you can see I have an ID and Blueberry, and if I just want to show you that at the same time the records are getting published here as well. Can you read this? So if I rerun it again, it should fail, or let's make it fail even faster by removing the randomness. So order service, I can just throw the exception directly and comment it out. And as you can see now, it will fail the test. Oh, and here is thread.sleep. Why is that? And if I take a look, just assume it fails, because there is something I missed in the configuration, perhaps. No, it indeed failed. You can see the database is empty. When you are reading, however, look even like how flaky this solution is. So if I do here like this .template.send here, and for example, I just invoke on this future .get here, things will start to, you know, go a bit more crazy. So just, you know, just think about it, because, you know, doing the two-phase transactions are not a good idea, and it can sincerely, you know, give you some good troubles, and maybe try to design your business case a bit different. One more thing here is when we are reading messages from so Kafka, sometimes you may end up noticing messages which you don't expect. So remember the concept of smart consumers and dumb brokers? So when you are reading messages from Kafka, you have to, by default, you read the messages which are uncommitted. So Kafka transactions basically just put the messages, and when you are reading, the broker say, okay, you put it just the messages, but when you are reading, you can read uncommitted changes. If you want to read only committed things, you have to adjust the property files by mentioning the correct isolation level, and these properties you can check on the Kafka documentation. So here are, for example, isolation level, and there are a bunch of properties which you can use. And the last thing of the talk which I want to show you is at Santu. So this little piece of annotation comes super handy in designing some, let's say, dynamic code. So for example, let's say we invoke this Kafka listener, and when we invoke it, we want to mark something is fraud, basically. And what we can do here is we say, okay, if the payload contains bar, then just throw it on this topic, just forward it on this Kafka topic. You don't have to hardcore like the conditions here or here. You can use SPEL, Spring Properties Expression Language, and you can do some more custom runtime things. And this thing here, for example, so I'm just switching back to this and just removing this to foo. And let's go. So in Spring Kafka, one last thing I want to show you before ending up this demo is, oh, and I forgot here, is, no, seriously, okay, never mind, is that when you are, now it's added like listener container idle event. So when you are doing processing in your consumer, sometimes you don't know whether your consumer is like gone or it is a bit slow because it is doing some asynchronous processing. What you can do is you can use either annotation like @EventListener, and you can pass the condition. Please note here the name of this should match this because it is listening, like there are a bunch of threads and stuff going on. So you want to be very specific. And then you can decide what you want to do. So for example, in event, you have access to consumer object, and you can, for example, I don't know, resume the consumer or, check the offset, what is going on. So this is a nice nifty thing which is added in Spring Kafka. All right, so the last slide. What we were able to achieve with Spring Kafka and Kafka, well, till now we achieved this much. So we had like something like 3 million reads per second. We could do more than 500,000 writes per second. We have, as I mentioned, 30 billion events. The replay time is even 2.7 hours, if I remember, but just to be on the safer side, I didn't measure it with the clock, so I put here. One thing which you should note is that we hit the hardware limits rather than Kafka's. So we can bump these numbers up as much as we want. All right, so thank you very much for listening. And just wait, I need to take the photo.